the following initial value problem. So we got x dy over dx plus 2y equals sine x over x. Y at pi, that's the x value. Y value is 0 when x is pi and x is positive. So here y is the dependent variable and x is the independent variable because this is on the bottom. And we know that when we have the following, I mean, this is not separable. So why is it not separable? Because y and dy over dx are not in product. Okay, y in only one place here, and plus means second. This is a separate term with dy over dx. That means we cannot separate x and y, and we got another x term here. Not separable. Is it a linear? Let's check the following form. And when we have some function of x, some dependent variable y plus dy over dx, and we can have a function of independent variable. A function of independent variable equals a function of independent variable, which is x. We can have constants as well. Okay, if we have this situation, then this is linear. In fact, we can divide by that function of x, and we will have exactly the following form: dy over dx. We call whatever that function is px equals, and left over is qx. So this is linear in the standard form of linear in terms of y, in dependent variable y with respect to x. And when we have a linear, we know how to solve. So we can find integrating factor, okay, which is e raised to integral of this function. Could be negative, that function. Then we multiply through by integrating factor. Then when we multiply through, then the left hand side automatically becomes derivative of dependent variable and integrating factor. Okay, this will be always the case. Equals, we multiply right hand side by integrating factor, then integrate. Okay, that's the procedure. So let's apply that here, because this is a linear, because we can divide through by x, and this will be exactly in this form. Okay, so divide this differential equation. So let me circle this one. Divide through by x. X is not equal to 0 because x is positive, so we can divide through. When we divide through by x, this is dy over dx plus divide by x. So I want to write in this way: 2 over x as a function of x times y. Because divide by x means multiply x on the bottom. Let me put sine x over x squared. In fact, this is exactly in this form now. Function of x, y dy over dx. So linear. Linear means we find integrating factor. Okay, let me write integrating factor. Mu x is e raised to integral of this function, which is 2 over x dx. So e raised to, let's integrate, 2 is outside, then 1 over x dx. So e raised to 2, antiderivative of 1 over x is natural log of x, absolute x, but x is positive, so we don't need absolute value. Then e and natural log actions cancel if they are adjacent, so we need to move 2 there, so that e raised to natural log of x squared. Now e and natural log, their actions cancel, x squared. Now we multiply this differential equation on both sides by x squared. Then the differential equation, ordinary differential equation, becomes, we are multiplying both sides by x squared. And this is integrating factor. That means left hand side automatically becomes derivative of dependent variable y times integrating factor x squared, equals multiply right hand side by x squared. We have sine x over x squared times x squared. So simply sine x left over. Now we integrate both sides with respect to x. Okay. Let's do that. So let's integrate both sides with respect to x. Then this is integrate. So when we integrate, y times x squared equals antiderivative of sine x. That's negative cosine x. Okay, plus c. Okay, now this plus c, the integration constant, the value of that constant of integration can be evaluated using this initial value. Okay, we can find the value of c now, then solve for y, or we can isolate y now, then find the value of c. So let's find the value of c first. So then we're gonna use this. Let me write over here. So using the initial value, which is y at pi equals 0, that means y is 0 when x equals pi. So y is 0 when x is pi minus cosine pi plus c. So this is 0. So 0 times the number is 0. Cosine pi, that's from the unit circle, or use a calculator, that's negative 1. Minus negative 1 is just 1 plus c. Subtract 1 from both sides, so c equals negative 1. Now we plug this c here. Okay, plug in here, and eventually we need to solve for y. Plug in there, then we got y times x squared equals negative cosine x plus c. C happens to be negative 1. Now divide both sides by x squared, so y equals negative cosine x over x squared minus 1 over x squared. Okay, that's the final answer.